into octal number. We'll see the example 1, right? So 153 base 10. It should be converted into the octal number. Octal number means base 8. What is that octal number? 0, 1, 2, 3, 4, 5, 6 and 7. Up to 7 only. 8 will not come. Right? Here we need to convert this decimal number into octal number. How will you convert? This decimal number is divided by 8. Previous case we divided by 2. Previous case we converted decimal to binary. Binary means base 2. So we divided by 2. Here we are going to convert decimal to octal. Octal means base 8. So it should be divided by 8. So 153 is divided by 8. It goes 19 times. The balance is 1. Again 19 is divided by 8. It goes 2 times. 2 into 8, 16. So the balance is 3. Now write in the reverse order. 231, 231. Right? So the octal equivalent of the binary decimal number 153 is nothing but 231. How we did? It is divided by 8. We need to divide by 8 and write the remainder separately. Now we'll go to the second example. 926. We need to convert 926 into octal number. What we need to do? 926 is divided by 8. Right? So while dividing it goes 1 times, 115 times, the balance is 6. Again this 115 is divided by 8. It goes 14 times, the balance is 3. Again 14 is divided by 8. It goes 1 time, the balance is 6. Now we need to write in the reverse order. 1636. So this is the octal equivalent of a binary of a decimal number 926. Right? 1636. How we did? It's divided by 8. At the time of dividing each and every stage we need to write the remainder in the separately. These remainders are written in this reverse order in order to get the octal number. Right? We'll go to one more example. Converting from binary by converting from decimal to octal. So here the decimal points available. 645.926. Right? The decimal points also available. What we need to do? First 645 is converted as usual, as like a previous problem. This 0.926 is multiplied by 8, very similar to decimal. In decimal we multiplied by 2, here we need to multiply by 8. Right? So first we'll go to the 8, first we'll go to 645. The 645 while dividing 8, it goes 8 times, 80 times and the remainder is 5. Then 80 is divided by 8, it goes 10 times, balance is 0. 10 is divided by 8, it goes 1 time, the balance is 2. So write in the reverse order 1205. So 1205 is the octal equivalent of the decimal number 645. Now we need to convert this 0.926 into octal. What we need to do? 0.926 should be multiplied by 8. The binary mean multiplied by 2, it is now multiplied by 8. It is 7.408. Write the 7 separately, 0.408 again multiply by 8. So what is the number? 3.264. So write the 3 separately, 0.264 is again multiplied. It is 2.112. Write the 2 separately, 0.112 again multiply by 8. It is 0.896. So here only we got 0. So it is written 0. So you can go like this. But normally we'll go 2 or 3 or 4 digits. Now this write this digit in a downward order. 7320. So 7320 is the octal equivalent of this decimal number 0.926. Right? Now 645.926 is now converted into octal 1205.7320. Right? 645 is converted as usual, division. This 0.926 is converted by multiplication. The first digits are retained, the remaining digits are again and again multiplied. Right? So we completed the second part, decimal to octal. Now we'll go to decimal to hexadecimal. The third one, converting from decimal to hexadecimal.